All right, we're in Unit 2, Lesson 8. We're starting a new chapter in the textbook with this lesson. This is Chapter 8, Section 1 out of the textbook, and we'll be talking about multiplying and dividing rational expressions. And all of Chapter 8 is about rational expressions. So we have a content standard that we're going to be talking about in this lesson, and that is APR 7. Which says, understand that rational expressions form a system analogous to the rational numbers. They're closed under addition, subtraction, multiplication, and division by a non-zero rational expression. We are also going to add, subtract, multiply, and divide rational expressions. That was a complicated way to say that all the rules for addition, subtraction, multiplication, and division apply to these problems. So we're going to continue following the rules that we've always followed. Our mathematical practice is, again, practice 8, looking for and expressing regularity in repeated reasoning. So we have spent a lot of time factoring polynomials. What we're going to be doing in this lesson is simplifying rational expressions and complex fractions. So obviously you may not know those terms, rational expression and complex fraction, but when we get to them in the lesson, we'll definitely make sure I talk about it so you understand what's going on. So example 1, simplify a rational expression. Okay, so what's a rational expression? Rational, ratio, fraction, that's what it means. You're looking at a fraction, an expression that has a fraction in it. And you're going to have some terms, some algebraic, some variable terms. What we're trying to do here is see what we can simplify by seeing if anything cancels on the top and the bottom. So hopefully you should notice right off the bat that there is a y plus 7 on the top and the bottom. So we're going to cancel those out. And that means we would be left with 3y over y squared minus 9. And there's nothing else that they have in common, so that's our final answer. Okay, part B. This time they want to know what conditions is the expression undefined. So functions are undefined. Fractions in general are undefined when the denominator is 0. Just like you can't divide by 0, you can't have this fraction here equal to 0. So we want to find out when does y plus 7 equal 0, and when does y squared minus 9 equal 0. So hopefully you can realize pretty quickly that negative 7 would not be an acceptable value for y, since that would make this first piece equal to 0. And then what they did is they went ahead and factored y squared minus 9 into y minus 3 and y plus 3. You should recognize by now that this is a difference of squares. 9 is 3 squared, so we have plus 3 minus 3. So we have negative 7 from here, that would make it 0. We have positive 3 from here, and negative 3 from here. So our three values that make it undefined are negative 7, 3, and negative 3. All right, check your progress. We've got a couple problems here. Part A, we're going to simplify this time. All we're doing is simplifying. When you have your answer, go on to the next slide. And again, this one was pretty easy. You should have quickly seen the answer was B. Going on to part B now, we're going to find what conditions make this expression undefined. I'm pretty sure this got to be a typo. This should say x plus 5, not y plus 5. Let me try to write over that real quick. I don't know why the book messed up, but that should definitely be an x. All right, when you have your answer, go on to the next slide. All right, so this time we have c. If we put in -5 here, this would be equal to 0, and this is another difference of squares from 4, so we have plus or minus 4 also. All right, example 2. This is something that you might see on the SAT. It says, for which value or values of p is the fraction p squared plus 2p minus 3 over p squared minus 2p minus 15 undefined? So we want to figure out what values of p make this denominator equal to 0. And you can see that this is a quadratic expression, and so we're going to try to factor this and find the factors that would make it equal to 0. So when we factor p squared minus 2p minus 15, you should quickly recognize that the two factors are -5 and 3. So p minus 5 and p plus 3. 5 would make this piece equal to 0, and -3 would make this piece equal to 0. So our two answers are 5 and -3. And that was choice B, if you didn't remember what the original choices were. All right, check your progress problem. Go ahead and figure out which values of p would make this fraction undefined. When you have your answer, go on to the next slide. Shockingly, it's D. Notice it's a quadratic, so there's two roots. This is the only choice that had two answers. All right, example 3. This time we're going to be simplifying using -1. So somewhere in here, -1 is going to show up, and you have no idea what that means right now, but that's okay. Let's go ahead and look and see. We've got two terms up top and two terms on the bottom. We're going to see what they have in common and try to factor that out. We're doing the greatest common factor on these two terms. Hopefully you can see from the top that each term has a to the fourth, so they take out a to the fourth, and you'd be left with b minus 2. On the bottom, each term has a cubed, so we take a cubed out, and we're left this time with 2 minus b. And you can see these things are pretty similar to each other. They're just flipped. The order is flipped. When you have the order flipped, if you multiply it by -1, then it flips it back into the correct order that you're looking for. So if you take b minus 2 and you multiply it by -1, then you're going to get 2 minus b. So basically, if I add in a -1 here and flip it around, this expression right here in red, let me circle it in red. This expression right here is equivalent to this expression right here, which is why they've replaced it. And when they replace it, they want you to recognize that there is now a 2 minus b on the top and the bottom, which you can cancel out. The a to the fourth over a to the third, remember you're subtracting powers here. 4 minus 3 leaves you with 1 power of a. So we've got 1 power of a, we've got this -1, and everything on the denominator canceled out, so your answer is just -a. All right, let's look at a check your progress problem. We've got another fraction here. Go ahead and see what you can simplify. When you have your answer, go on to the next screen. Okay, our answer this time is -x. All right, here's our key concept. This is hopefully going to be really simple to you. I don't think it's a major thing that they're telling you, but basically what it says is if you want to multiply two expressions together, you multiply the numerators, you multiply the denominators. So if you have a over b times c over d, you just do a times c in the top and b times d on the bottom. If you're dividing two things, like you have a over b divided by c over d, I think you've learned this before with fractions, but you flip the second fraction over and the division sign changes to multiplication. And if you've learned that before, then this is not going to be anything different or new for you. So let's practice some of this stuff. So example 4, we're multiplying two rational expressions together. We've got 8x over 21y cubed times 7y squared over 16x cubed. Now I think the easiest thing to do with this stuff is to write out and show your simplification. I do it here. I need to make sure I have the right tool working. Okay. So I see, does 8 go into 21? Nope, it doesn't. Does 8 go into 16? Sure it does. If I cancel out 8 over 16, that's just 1/2. So this is a 1, this is a 2. 7 over 21. That also simplifies into 1 over 3. Then I have x over x to the third. If I subtract powers, 1 minus 3, that means I'm left with 2 on the bottom, x squared. And 2 over 3, 2 minus 3 is -1, so I'm left with 1 power of y on the bottom. So all of this, to me, simplifies. All I have left on the top is just 1 times 1. That's just 1 over, I've got 3 times 2. That's 6. I've got an x squared. And I've got a y. And I'm done. And that's how simple it can be. Now I'm going to show you what they do here, because they write out every single term. Basically, they took the 8 and they wrote out the factors of 8. 2 times 2 times 2 times the x times the 7. Y times y, that's how you get y squared. They're going to write out every single term, and then they're going to cancel just one by one. And then everything that's left over, that's what they write here, and then they combine that stuff. You can do it this way if you like. If you need to see things written out, I suggest you do this. But obviously this is a lot more writing. But if you need to do the more writing, do it this way. If you can do the simplification quickly like I showed originally, do it that way. If you're confident that you won't mess up. But if you think you might mess up, go ahead and write some of these out until you get good and you've practiced these a few times writing everything out. All right, part B, we're going to try a division problem. Remember that for division, we flip the second term over and change the division sign to a multiplication sign. So we've got this expression right here. They write everything out again, cancel stuff, get here. I'm going to show you real quick. If I cancel these, I see 10 over 5. 10 over 5 is 2. 6 divided by 3, that's another 2. Let's see, I've got m to the first over m to the fifth. That means there's 4 powers of m on the bottom. I see k squared, don't see any other k's. Okay, that's going to stay the same. I see c to the second and another c to the second. Those just cancel out. And I see d to the second and d to the first. 2 minus 1 is 1, so there's 1 power of d on the top. Sorry, that's a bad looking d. Anyway, we've got 2 times 2. That gives me 4. I've got a k squared and I've got d on top. So I'm going to put in alphabetical order, put the d first, and then k to the second power.